Alright. What I want to do, because numbers 1B and what else is on the front there? 1B and number 2 are pretty much reflections of this information and nothing new. And number 4 is also. But when we get to number 5, we hit, and number 6 is easy peasy too. Number 6 is one of these. So let's do number 5 together, then I'll release you to finish this sheet, and if you are finished, I have 2 more problems for you to do. Alright, so the difference on number 5 is I'm going to teach you a new aspect of this. So far, we have, do you have this down? Can I erase it? Do you have number 1, A, and 3 if you needed it? Do you have it? Number 3? Looks like you do. Did you get it all the way? Yep. Alright, I can erase. Alright. This all the erasures I have, so I gotta make them last all day through 3 classes. Alright, while I'm erasing, Brian, would you read for us number 5? We're gonna work this one together because there's something new on number 5. Are you keeping an eye on the time at all?
Nope.
Yeah, it's been like 5 minutes.
Yeah,
All right.
it's 9 o'clock.
Let me go ahead and we'll just do, say 8 more minutes. I think that would work. Alright, it's the timer. 8, you can't do seconds on my timer. Alright, I set it for 8 minutes. Alright, hopefully that'll work. I learned how to split them up anyway, so it's no big deal. It's just easier just to divide them up here. On number 5, Brian, would you read that, please?
What is the mass of the meter stick shown in the figure? And this 25% of the meter stick's mass is to the left of the fulcrum, and 75% is to the right of the fulcrum. And it is staying balanced somehow.
Alright, so we are putting a 1 kilogram mass here, and is sitting here at the 25 centimeter mark, and the whole thing is 100 centimeters. 25% and 75% of the mass of the meter stick. So here's what's different, the striped area. Up till now, we have ignored the mass of the meter stick. So in the first, or the mass of the seesaw board. So we have largely ignored that, and that's fine during learning process. But really, anything that has mass has weight, and it's creating its own torque. So in number 5, we have only the mass of the meter stick to balance this 1 kilogram mass over here. So we have to include the mass of the meter stick, and let me show you how that works. Alright, so what you need to know is, alright, here's the mass of, I'm going to do this one in blue. Here's the mass of the meter stick on this side of the axis of rotation, okay, the blue part. Whenever I have a force created from a mass's weight, I have a spot that we measure from. So when I look at this 1 kilogram mass, I will change that to weight, which is what, 9.8 newtons. Weight equals mg, right? So I always need to know the distance from the fulcrum. So for that one, it is 25 centimeters, which is 0.25. So I'm going to start my sum of the torques equals 0. So I'm going to have 9.8 is the weight created by that mass. It's 25 centimeters or 0.25 meters. So nothing new so far. But now I'm going to have to include, so which way is this one? Emily 1, you're good at these.
Negative.
Thank you. So this one is a negative torque, but there is a mass over here just by the meter stick itself. I've shaded it and striped it in blue, where I need a spot to calculate its distance from the fulcrum, because the meter stick goes from here to here. So what I need to train you in, when it's a mass like that, you're gonna take its center of mass. That's where you're going to calculate its weight from. So you're gonna eyeball this side of the meter stick and find the center of it. Right there is where you're gonna calculate the weight of that meter stick. So where is that on this one? It's halfway between, Emily, halfway in between what two measurements?
50 and 75.
All right, so can you figure that out for me, what it would be? It's 50 and 75, so it's, I need its
62.5.
distance from there. Pardon?
62.5?
52?
60.
Oh, sorry, 62.5. 62.5. 62.5. I think you're right, because there's 25, between 50 and 75, there's 25,
Divide
right?
by 2,
So we're gonna go divide that by 2.
which is 12.5, and then add that to 50.
12.5, and add it to the 50. So we get 62.5 centimeters. So I'm going to add then this torque. Well, this torque will be causing a rotation that way, yes. Oh. This torque will cause a rotation that way. And so I'm going to add it, because it's going to be a positive torque. And its distance from the fulcrum then, according to Emily, is 62.625 in meters.
I thought it was.
I'm sorry?
Is it 0.0?
No, because you move it twice.
Yeah, from meters, centimeters to meters, you just go over twice, so.
Oh, right. I
we're
said
good.
divided by 1,700.
So this is meters, this was meters, this is newtons, and so now I need the weight, or I need the mass of the meter stick, and I don't know it, but I'll say, I'll say mass of the meter stick, is that our symbol? The mass of the meter stick, but I know it's 75% of the mass of the meter stick is on this side. So instead of a mass of the meter stick, I'm going to put 0.75 mass of the meter stick. But I'm not working in mass. So what do I have to remember over here? I'm working in newtons. So what do I have to do, Emily, to
Convert it.
And what will I multiply by to get mass?
Times 9.8.
9.8. So I'll just throw that in the equation, and I'll grab it later. So do you see, so far, I have a torque created from this mass, and its location is 0.25 meters from the fulcrum. And then I have a torque created by this side of the meter stick. And I'm not quite done. When I have all of the torques, they're going to add up to 0. Why did I leave a space? Can you think of any other torque that I'm missing here?